Right, today we're going to look at the laws of exponents. First, we're going to start with what we call the multiplication rule. And the multiplication rule says that if you have a base, like a variable or a number, raised to a power, we'll call it m, times the same base, whether it was the same variable or a same number, to a different power, or maybe the same one, n, then all we do is we keep the base and add the exponents. All right? So it goes like this. When we're multiplying like bases, or same bases, we keep the base and add the exponents. So as you go through this, we're going to see it and hear it over and over, and you want to say it in your head so you know the rule. Okay, so we'll start with our first example. We have x to the third power times x to the fifth power. So x to the third power we know is x times x times x. And x to the fifth power is x times x times x times x times x. And that's its meaning. All of these are to the first power. And we have 1, 2, 3, 4, 5, 6, 7, 8 of them. So it's x to the 8th power. So our shortcut rule here is that we look and we say, okay, we have x to the third times x to the fifth. The base is x, so we keep the base when we are multiplying like bases. So we keep x. And we add the exponents, and we say 3 plus 5. So we say it's going to be x to the 8th. So instead of writing this out 8 times, you can take the shortcut rule. And that works really well, especially when you have negative exponents or you have exponents that are very high. Let's look at another example, okay? There's another rule that we have to know about, and right now you're going to take it on faith, okay? When we get into the division rule, we'll see why this happens, but for now, you're going to take it for what it is. It's called the zero power rule. Any base, variable or number, raised to a zero power equals 1. End of story. That's it. So any variable or number or expression that is raised to the zero power, it always equals 1. So 2 raised to the 0 power equals 1. X raised to the 0 power equals 1. The expression xyz, all raised to the 0 power, equals 1. 2 squared, b squared, c to the 4th, all raised to the 0 power equals 1. So you have to look and see where is that 0 power. If it's outside a quantity, it's 1. If it's a variable by itself or a number by itself, then those numbers or variables to the 0 power equal 1. It's a very powerful rule, and when we get into the division rules, I will explain why that happens. But for now, take it on faith. Okay, not all exponents are positive, so let's take a look now employing these two rules, multiplication and 0 power rule. If we have r to the negative 1 power times r to the 4th power, we are multiplying like bases called r. And when we multiply like bases, we keep the base and add the exponents. So negative 1 plus 4 gives us 3. So it becomes r to the 3rd power. All right, next one, x to the 0 power times x to the 0 power times x to the 0 power. Any variable or number or expression to the 0 power is 1. So this becomes 1 times x to the 0 power. Again, it's 1 times x to the 0 power. Again, this is 1. So what we have is 1 times 1 times 1, and that equals 1. And that's your final answer. Okay, let's look at a couple of examples that start to change it up a little bit. All right, we have m times m to the 4th. We are multiplying like bases m. So we're going to keep the m, and keep the base. This m doesn't look like it has a power. When it doesn't look like it has a power, or you can't see the power, it is 1. You should write it for a while until you get adjusted to the fact that there is a power there. If there wasn't a power there, you wouldn't see the variable. So now we have m to the 1st times m to the 4th. Multiply like bases, we keep the base, add the exponents. Your exponent should be something different than 4 because we are multiplying by another variable. So make sure you keep in mind, if you wind up with the same answer as what you have in the problem, something's wrong here. All right, you got to put that 1 power on the m. Okay, another example we'll make up is, let's say we have a squared times a cubed. All right, a squared times a. There's a 1 power here. So this is going to give us a to the third. But we still got to bring this down times a cubed. A cubed times a cubed, multiply like bases, keep the base, add the exponents, a to the 6th. You could have also done that here. We're multiplying the same base across. 2 plus 1 plus 3 is 6, so a to the 6th. All right, next problem. V to the negative 2 times v to the negative 3. All right, same base is being multiplied. Keep the base, add the exponents. Now I know we've stayed away from double signs, okay? However, in this case, you'll probably want to see this. So it's negative 2 plus a negative 3. So you're going to get v to the negative 5th power. Okay, there will be another lesson on what to do with negative powers, but for now, this is okay. All right, last examples. X to the 0 times y to the 0 times z to the 6th times x to the negative 2nd, y to the 0, and z to the 1st. In between each of these variables is implied multiplication, just as we have grown to know it through our course. Okay, so we're going to start. X to the 0 power, that's 1, times y to the 0 power. Well, that's 1. So now I have 1 times 1, times z to the 6th. So I would, on this one, take, all right, z to the 6th comes down, because 1 times z to the 6th is z to the 6th. Now, let's deal with this. X to the 2nd power, negative 2nd power comes down. Y to the 0 power is 1, so times 1. Z to the 1st will come down, and now we're going to multiply this. Okay, so we've got z to the 6th here times x to the negative 2nd times 1 doesn't change anything, so that goes away, times z to the 1st. Now you need to sweep through again and see if there are any like bases. Now, what I usually do is I'll say, all right, if I have like bases, I have a z to the 6th, and over here I have a z to the 1st. We remember that multiplication is commutative, which means we can multiply in any order and get the same answer. So I will put my z's together. So z to the 6th times z to the 1st. That way they're together. And then I'll times it by x to the negative 2nd. And here, z to the 6th times z to the 1st is z to the 7th, because I keep my base and add my exponents. 6 plus 1 gives me 7. And then x to the negative 2nd comes along with it, and your final answer is z to the 7th, x to the negative 2nd. You could have also written it as x to the negative 2nd times z to the 7th. That is fine. You don't need to show the multiplication symbol in between the variables and their powers. It's understood. All right, our last problem is the quantity of a squared b cubed c to the negative 1st. Notice there's no plus or minus signs in here, but these are bundled together, times, because that's implied here, a to the negative 4th, b to the 5th, and c to the negative 2nd. So what I'm going to do is look through and say, hey, I've got a's in both of these quantities, I've got b's in both of these quantities, and I've got c's in both of these quantities. So I'm going to bundle my a's, my b's, and my c's. So this is a squared, knocked him off, times a to the negative 4th. So they're together. I put a check mark so I can see that I've already dealt with them. Then I have b cubed times b to the 5th. Then I have c to the negative 1st times c to the negative 2nd. And now one by one I go through and I multiply my a's, my b's, and my c's, and then put them together as one final product. All right, when you're multiplying like bases, you keep your base of a, and you add 2 plus negative 4, which gives you negative 2. So this becomes a to the negative second power. For b, it's b cubed times b to the fifth. When you multiply like bases, you keep your base. You add 3 plus 5, and you get 8. For c, we're multiplying like bases. We keep our base, and we add our exponents of negative 1 plus a negative 2, which gives us negative 3. And for simplicity, we know that the implication between the variables, when we do not see a plus or a minus sign, is multiplication. So we can just write it as a to the negative second, b to the eighth, c to the negative third. If you like a little bit of chaos, you could have written this as b to the eighth, a to the negative second, c to the negative third. It does not have to be alphabetical, but for some folks that works best. So, in summary, when we are multiplying like bases, we keep our base and we add our exponents. When we have zero property rule to be used, that means that any variable, expression, or number raised to a 0 power equals 1.